Okay. Good afternoon, all of you. In today's session of class 12 chemistry, we are going to discuss electrical properties of solids. So, if you consider a solid like sodium, so 1s2, 2s2, 2p6, 3s1 is the configuration of sodium. So, this is what actually happens is that you have to understand that solids they have rigidity. Solids have rigidity. In a given mass of solid, all the atoms will be very close to each other. Solids are known for their rigidity. So, if you look at sodium 1s2, 2s2, 2p6, 3s1, then or rather if you just look at any solid for that matter, so the atoms are all very close to each other. Because of the rigidity of the solid, the atoms are very close to each other. And when the atoms are close to each other, then what we have studied in atomic structure, the concept of discrete energy. So because the atoms are very close to each other, instead of having discrete energy, they have a range of energy, and that is known as energy band. Okay, so instead of having discrete energy, they have a range of energy which is known as energy band. So basically this is the energy band diagram for sodium. This is the 1s energy band, this is the 2s energy band, this is the 2p band, and this is the 3s band. So these are the energy bands in case of these are the energy bands in case of sodium. Now the 3s band is partially shaded and partially is not shaded. The reason is that the shaded portion is called valence band, and this portion is called conduction band. So the valence band is the portion which is shaded, and the conduction band is the portion which is not shaded, right? And the electron which is there in the valence band, that electron, it just requires a very small amount of energy to go to the conduction band, and once it goes to the conduction band, it becomes a free electron. That means it becomes available for conduction, and that is why sodium is considered to be a good conductor. Now, suppose let us say you are drawing the energy band for zinc. So for zinc, 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2. So for zinc, this will be the 1s orbital, right? And this will be the 4s band. So 4s band is fully shaded because it is fully occupied, and 4p band is completely empty. But 4s and 4p band has got an overlap. That means the energy levels of 4s and 4p has got an overlap, and due to the overlap, a 4s electron will easily be able to go to 4p. And once again, when that happens, it will become available for conduction. So this is the situation with zinc, right? So this one is for sodium and this is for zinc. So now suppose if you are talking about something like silicon or germanium, so in silicon or germanium the valence band and conduction band will neither be back to back like sodium, nor will they have overlap like zinc. But the gap between valence band and conduction band will be quite small. Obviously, even though the gap is small, it is considerably more than here, because here there is an overlap, and here because it is back to back. So here, even though the gap is small, but it is considerably more than these two. So silicon and germanium are called semiconductors because there is a gap, but the energy needed to promote an electron from valence to conduction band is significantly higher than the energy needed here or the energy needed here. And that is why they are called semiconductors, because their conducting nature is between conductors and insulators. And finally, if you look at an insulator like diamond, so if you look at an insulator like diamond, so in case of diamond, this is the valence band, this is the conduction band, and the gap between the valence and the conduction band is, there is quite a large gap. In fact, the gap is so huge that it is virtually impossible. It is impossible for a valence band electron to go to conduction band. So now you can see that why diamond and insulators have got such poor conductivity, and why conductors like sodium and zinc have good conductivity, and why semiconductors conductivity is between that of conductors and insulators. So this is our topic for today, and based on this topic, okay, based on this topic which we have done, so I would like all of you, your homework is you have to draw the energy band diagram. You have to draw the energy band diagram for potassium and copper. So you know that potassium and copper both are metals. So you have to draw the energy band diagram. You can take the hint from whatever techniques I have shown you and just try to draw a representative energy band diagram for potassium and copper. That is your homework, and you can submit the homework anytime by 9 p.m. tomorrow, that is 9 p.m. Thursday. That's it. Bye all of you.